I'm Jonathan Tompkin from the University of Illinois. Is there enough water? The UN estimates that there is a number of countries that use their water stocks unsustainably. If you look at this map, you might see if your country is one of those. So are consumers responsible? Is it running the taps at home while we brush our teeth, or taking too many showers that's causing water stress? Domestic use turns out to be only a small part of total water use. It is true that the water used in the home is often highly treated, and so it's a sort of a special case of water. And so I want you to be aware of this difference. When I'm talking about water stress, I'm normally talking about natural water processes, so rain water or river water or groundwater. So this isn't like the water that comes out of the tap necessarily. This water hasn't been treated, but is part of the hydrologic cycle. So when I talk about water stress, or the amount of water needed to make a product, I'm usually talking about this water in the natural system. Take this cup of coffee. How much water is used to make it? Well, we need about 250 millilitres, that's 1 cup, of treated water to make the cup of coffee itself. But there's actually a lot of water that we can't see in this cup. What I'm thinking about here is that to make the coffee beans that were ground up and brewed to make this cup of coffee, we had to have irrigation, we had to have precipitation depending on the region. And it turns out that coffee beans have a very large amount of water embedded in them. And I'm going to use this term embedded a lot. So it's sort of like a hidden amount of water that was needed in their process. This is a similar idea when we might talk about embedded energy that you might need to, for example, make a car or an aluminum can. The irrigation that you need to make a cup of coffee is about 200 litres. So we have 200 litres of embedded water in this cup. So consumers use the water, but we just don't use it at home. So when we think about our water use, our domestic use is in fact only a tiny fraction of the total amount of water that we used. If you're a tea drinker, by the way, you can rest easy. Tea only needs about 1/10 as much water as coffee does per cup. As we discussed previously, most water is used for agriculture. It's difficult to be precise, but here are some estimates people have used for various embedded water measures for different industrial and agricultural objects. A kilogram of wheat requires about 1,300 litres of water, while rice requires about 3,500 litres of water per kilogram. Meat tends to require even more because most animals are fed crops that have been grown specifically as feed. So a kilogram of hamburger requires about 15,000 litres of water. That's around 4,000 gallons for 2 pounds of meat if you're from the United States. Industrial processes are often even more water dependent. Microchips are a great example. They need about 15,000 litres of water per kilogram of microchip. While a cotton shirt, of course you have to grow the cotton, is thought to require around 4,000 litres. Manufacturing a car might require as much as 500,000 litres of water. So whenever we consume any object, an industrial object or an agricultural object, we're actually using up some embedded water. Now this water is can be part of the natural hydrologic system, so it can be a renewable resource. But when we think about water use in the home, we should think less about the tap, the water coming out of the tap, and things like the tap itself, or the apple that we're washing. All of the things that we consume in the home, not just the flow of water that we can observe. This embedded water has a special name. It's often called virtual water. And this concept is important as it explains why we can have some regions that can use more water than they possess, but they still don't starve. Or indeed, they don't even die of thirst, right? We need water to drink as well. So consider this. Would you rather transport 1 metric tonne of rice or 3,400 metric tonnes of water? Clearly, the metric tonne of rice is much easier to move. And so by trading virtual water, we can replace the water needs of a region by bringing in agricultural and industrial goods that require large amounts of water production from other regions in the globe that are not water stressed. This is one way in which nations can cooperate to manage water resources. If we look around the world, there are some countries that are net water exporters in a sense. And remember, water is a renewable resource if it's used sustainably. So this is not a bad thing. It's not like North America, for example, is losing water when it exports water objects with lots of embedded water in them, such as meat or microchips for that matter. Canada and Australia are relatively rich in water, and so they produce lots of agricultural goods that require lots of water, like meat, beef, lamb. Water importing countries can export less water-intensive products in return. And so in this way, they can reduce the amount of water stress in those regions. This ideal arrangement is not always followed, however. Consider Yemen. Yemen is water poor and has a rapidly growing population. Poor policies can prevent a sustainable use of water resources. Yemen is thought to have around 200 cubic metres per person per year, which is well below what the UN considers a reasonable level of around 1,000 cubic metres per person per year. This is a country with many problems. It has many internal conflicts, there's a lot of poverty, and there's a lot of undemocratic and unresponsive government. The Institute for Economic and Peace gives it a global peace ranking of 119 out of 144, while the United Nations Development Programme Human Development Index is 140 out of 182 nations. So you can see this is a country that is in need of development to raise the standard of living for its citizens. Yemen's government has policies, however, that don't promote the sustainable use of water. For example, diesel power is subsidised, and diesel fuel is used in water pumps. So as a consequence, we see an over-extraction of water from the aquifers in Yemen. A lot of the water used in Yemen is to produce khat, which is a chewable leaf that creates a slight euphoric feeling. It's a drug. And as a consequence, much of its prime farmland and water is used in the production of a non-agricultural agricultural item that's not for food. And so 80% of all food in Yemen is imported. Because of this overuse of Yemen's aquifers, the water table in Yemen is dropping. If we talk about it in terms of a flux, if we have, for every 1 gallon of flux, that is sustainable flow, 4 gallons are removed. So of course I could say 1 litre and 4 litres are removed. So the stock is being depleted much faster than it can be replaced by the natural hydrologic cycle. Some wells have been contaminated by seawater because if you lower the water table by enough, then salt water from outside will be attracted inland. Remember, just like on the surface, water wants to flow downhill. And under the surface of the earth, the downhill is determined by the height of the water. So if you have contamination from the ocean, then that means that your aquifer becomes salty, and so you can no longer use it for drinking or for agriculture. What's more, and in this way Yemen is typical of countries that face future water stress, there's lots of population growth. Currently it's about 7% per year. In fact, it's predicted that local water sources will run out by 2017. This is a very serious problem in a country where half the population lives on less than $2 a day. Most places are not in such a dire situation, but we can still learn lessons from places that are not managing water sustainably. I've talked a little bit about water tables dropping and overuse of water and the loss of stocks. But as we saw in the Yemen example, another threat to sustainable water use is pollution. Water pollution is an issue in many places, because water can be polluted in many ways. And if we pollute an aquifer, that might be the equivalent of removing all the water from the aquifer, as far as we're concerned. If there are heavy metals or or organic compounds that cause cancer in a water resource, then we can no longer use it. Industrial and agricultural processes both create pollution. Sometimes we can see this locally with things like sewage overflow. There are lots of examples in the textbook. And we can also see this on a small scale with industry. For many years, of course, in the United States, there's been a large dry cleaning business, and this wasn't regulated. It turns out that fluids used in dry cleaning poison local aquifers. So again, if we don't know very much about the natural system, we can damage it and make it unsustainable without being aware. In the state of Illinois, officials recently identified 415 dry cleaners where spills of PCE, which is a toxic solvent, have damaged the local aquifers. For a long time, it wasn't well understood what PCE would do in the natural environment. And although I'm not spending very much time of it in this course, another extremely important issue in terms of human development is sanitation. A staggering large amount of people around the world lack access to clean water. And this is a human development issue, which I think in turn makes it an important sustainability issue. The United Nations estimates that about 2.5 billion people do not have improved sanitation. And around 1.1 billion people practice open defecation because they don't have flush toilets or even pit toilets. So you can again see how this creates a cycle because we're damaging water resources at the surface by polluting them, and so this reduces the potential for development. So the demands for water are only set to increase. More people, more agriculture, more industry means we need more water. This will particularly be an issue in places with growing populations. As we saw when we talked about population in week 2, the one place in the world where this is set to increase the most over this century is Africa. India is also a place with a large population increase, and they are also a place that appears to be set for increased water stress. Here we see in this graph a list of countries and UN judgment onto whether or not they are under water stress now or if they will be in the future. As you can see, many places in Africa already are under water stress. And as I said in the last lecture, note that we don't really see water wars per se in these places now, even though these countries are currently under water stress. That is, they don't have quite enough water to meet all their needs. But again, water is very important for development. We need clean water to improve sanitation and to reduce disease. We need water for agriculture and industrial development. So if we don't have enough water, these countries will find growth in their development much harder. As we saw in the Yemen example, however, there's lots of scope for improvement with improved policies. When we talk about policies next week, you might get a sense of how water use can be better managed. We'll touch on this in the next lecture as well. Before I move on to the next lecture, I want to leave a final thought, is that so far I've been talking about water from a human-centric point of view. And one thing I'd like to underline is that the more we use the water, the more we take it away from natural systems. So it might in some ways be sustainable to use the flux of water in its entirety, but in practice we would be robbing the natural ecosystems. So if we value the natural world at all, we need to minimise the total amount of water that we extract so that there is enough for the natural systems, for the forests, for the rivers, and so on. In the next lecture, we'll talk about another major threat to world ecosystems. That is the clearing of land to grow crops. And this actually comes back to one of the most important issues in 21st century sustainability. Can we grow enough food to feed the extra billions?
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.